Welcome to today's webinar, Leapfrog Geothermal Best Practice for Interbedded Lithology Modeling. My name is Bastien Poux, and I am the Technical Sales Advisor for Energy at Sequent. It is my pleasure to host you today for this webinar. Please note, the objective of this webinar is to focus on the tools in Leapfrog Geothermal and to give you helpful workflow ideas and tips and tricks to elevate your modeling skills. The material covered in this webinar is meant to be high-level and is using a simplified dataset. Thanks to its powerful implicit modeling engine, Leapfrog Geothermal allows you to build complex geological models directly from your data. Its fast processing and dynamic modeling capabilities lets you easily build different models from the data to test different scenarios. During today's webinar, for example, we will see two different approaches to build a geological model from the well data available. This best practice webinar will focus on the use of the interval selection tool. This tool is used to process your well data before starting to build your geological model. Once imported and corrected, well data usually requires some processing. The interval selection tool is particularly useful if the lithologies in the column are poorly sorted and there is no possibility to use a query filter to classify them. This tool is meant to be used directly in the 3D scene of Leapfrog Geothermal and lets you select intervals to sort them into new units. Besides this tool, a couple tips and tricks will also be demonstrated during this webinar, including how to properly display the well ID above the topography, how to modify the boundary of a model and give them an irregular shape like we can see on the image on the right. And finally, we will use the freeze unfreeze tool to post-processing for some objects while working on the data. We are now in a new project in Leapfrog Geothermal. As a reminder, we have on the left the project tree. In the middle is the 3D scene. Below, we have the shape list, and at the bottom right, we have the property panel. We will start by adding the topography. I right-click on the topographies folder, new topography, and I am going to import an elevation grid. I look for my DEM model inside my folders, and I open it. The default resolution of my DEM model here is 100 meters. The model is going to be clipped to the bounding box. I can now import my DEM. The elevation grid is going to be loaded under my topography. I can slide it inside the 3D scene. Currently, the mesh has a flat color. If I want to display different colors, I can go in the shape list under the topography, and in the drop-down menu, I can select elevation. This will color my mesh based on elevation values. If I want to change the colors, I can go in the second drop-down menu and click on the pencil. The histogram of the elevation values is showing up. At the top left, I can change the color ramp. Here I'm going to choose the linear one that goes from green to orange to white. I can also change the location of the curve points simply by clicking on them and moving them. This will change the distribution of the colors, as you can see on the elevation grids in the background. I can now close my color map. The next thing we are going to do is add the well data. In my project tree, I can right-click on my well data to import new wells. In Leapfrog, we need three different types of files. First, the location, the survey, and the interval table. I'm going to browse for my location table in my folders and open it. Automatically here, Leapfrog has selected the survey file and the lithology table. If I wanted to add other table, I can simply click on the Add button, or I can also remove them. I'm going to now import my tables. The first table, location, has the well number, XYZ coordinates, and the total depth of the well. The survey table also has the well data, the depth, the dip, and the azimuth values to represent the well design. If you have the inclination value instead of the dip, you can also use it. The last table is the lithology table that contains all the information about the geology. It is an interval table with the lithology type selected as a lithology category. I can now import my wells. The wells are now loading into my project. I can see the location table, the survey, and the lithology table. If I click on the lithology and I drag it into the scene, I can now see my wells. At the moment, my wells are showing as lines. If I want to see them in 3D, I go in the shape list in the lithology, and I click on the little pink button to see them as tubes. Here they are quite large. I can change the line radius from 100 to 40. I can now see the different lithologies, and I'm going to activate the legend. If I want to change the color, I also go in the shape list and I click on Edit Colors. Here I'm going to put my basaltic flow as red, my basement as brown, and my tuff as yellow. And then I can click OK. The next thing I'm going to do is add the well numbers. For that, I drag in the location table. I'm going to start by making the wellhead as a sphere. I put it in 3D in the shape list, and I give it a radius of 20 meters. You will notice now that it is pretty hard to see the well number here. I'm going to change the color to white, but they are still hidden inside the topography. This is the first tip of this webinar. If I go in the property panel and I click on Format Display Text, I can simply add a few empty lines after the whole ID. This will lift the whole ID above the topography. It makes it much easier to see the well number when you move around the scene. Now, let's start to look at our well data. I'm turning off the topography. When I look at my well data, I can see an alternance of tuff and basaltic flows and the basement. What we want to do here is separate the two different basaltic flows. For this, we are going to use the interval selection tool. To access the interval selection tool, I am going to right-click on my lithology table, and under New Column, I will find the interval selection tool. My interval selection is going to be based on the lithology column. As I'm going to separate the different units, I am going to call it units, and click OK. A new window with the lithologies is going to appear, and also a set of new tools above the 3D scene. The first one is the stroke tool. This one will be used to select the intervals. The next one allows you to change the width of the stroke tool. The two following ones will be used to add or remove intervals to the selection. The next one lets you select all the visible intervals in the scene, or to remove all the selected intervals. And finally, the last button is to invert the current selection. I'm going to start by deactivating the other units, so the basement and the tuff, so I only see the basaltic flows. I then select the stroke tool, which is actually quite large at the moment. So I'm going to make it a bit smaller, from 50 down to 20. Now it will be much easier to select those intervals. I can draw a line across the intervals, and I can do it in several steps. If by mistake I select some other intervals, by selecting the Remove Interval button, and then using the Stroke tool to draw a line across them. They are now unselected. If I click on the Select All Interval button, it will select all the visible intervals, so not the basement and the tuff. I can also clear the selection. Now I'm going to select again my intervals, but for that I have to activate the Selection tool. So here I pick all the first intervals of basalt. If I click on the Inverse Selection button, I am selecting the other intervals that are visible in the scene. So now that I have selected all the intervals of my first basaltic flow, I'm going to click on Assign To and create a new lithology. This one will be called Basaltic Flow 1, and I can also change the color. I am going to select a lighter red. Now I can see my Basaltic Flow 1 as a new unit. If I click on the eye next to it, they're going to be hidden. What's left here is the second basaltic flow. I can now select all intervals, select Assign To, and create a new lithology for my basaltic flow number 2. I am also going to change the color to a red a bit darker so that we can see the difference between the two basaltic flows. And finally, I now need to save all the modification I've done by clicking on the Save button. And I can close the interval selection tool. I can now visualize also the other lithologies by clicking on Edit Color next to lithology and clicking on the eye to reactivate them all. We can now see here the different basaltic flows have been separated, so we are ready to build a geological model. In the project tree, we're going to right-click on Geological Model and select New Geological Model. We now see in the scene the boundary of the geological model, and the first thing we have to do is to select the base lithology column, the one we created with the interval selection tool called Units. We also have to define the resolution. We're going to pick here 100 meters. And we have to set the model extent to the lithology table. This will encompass all the wells, and I can then manually extend it using the red arrows on the side. The model extent can be changed at any time in the future, whereas the base lithology column cannot. And I click on OK. This will create a new geological model object. It will be based on the well data and the units. If I click on the lithologies under my geom, I can see that the lithologies here are the ones resulting from the interval selection. Basaltic flow 1 and basaltic flow 2 are present. I will then start building the surfaces and the basaltic flows in particular. First, the basaltic flow number 1 will be built as an intrusion. I can now select New Intrusion from Base Lithology. As the entire lithology, the one I'm modeling, I'm going to select Basaltic Flow 1. All the other lithologies are exteriors, so I can click OK. This will build a new surface, and I can drag it into the scene. What we see here is that the different intervals of basaltic flow number 1 are not connected. To connect them, I'm going to use a trend. For that, I start by drawing a new plane that goes through all the intervals. Then, I right-click on the basaltic flow and I open it. The last tab is called Trend. Here, I can set the trend from the plane by clicking on the Set From Plane button. The direction of the plane is going to automatically be integrated. I can change the ellipsoid ratios. I'm going to start with 10 and 10. This will apply a strong trend in the X and Y axis. The surface is now reprocessing and will update automatically in the scene. What we see now is that all the intervals are connected. If we wanted to stretch even more the lithology, we can change the values in the trend. I am going to change them to 12 and 12. It will reprocess the surface again and update it in the 3D scene. I will keep these values and I can deactivate the plane. Next, I'm going to work on the basaltic flow 2. I am going to build a new intrusion. So I right-click on Surface Chronology, New Intrusion from Base Lithology. Here, as the Interbedded Lithology, I select the basaltic flow number 2. The only younger lithology is basaltic flow 1 here. Even though it doesn't seem to be any contact between the two units, it's still better to put it here. I can now click on OK. Leapfrog is going to process my new surface, and when it's ready, I can drag it into the scene. I can observe here the same thing as for the first flow. So I'm going to draw a new plane that goes across the different intervals. And I'm going to use it the same way as for the first intrusion as a trend in the settings of the basaltic flow number 2. Click on Set from Plane. And I'm going to use the ellipsoid ratio of 10 and 10 to start with. And then I click OK. It is now reprocessing and updating in the 3D scene. What I see here is that the wells are pretty well connected, so there's not really any need to change the ellipsoid ratios. So I can remove my plane. Now we can look at both basaltic flows together. And the next surface to build is the contact between the tuff and the basement. For this, I am going to create a new surface as a deposit from a base lithology. For this deposit surface, I am going to select the tuff as the primary lithology. To represent the surface in contact with the basement, I select the contact below. I see that the tuff has contact below with the basaltic flows and also the basement. The basaltic flows are younger, so I move them to the ignored lithologies to only keep the 17 contacts with the basement. Now I can click OK to build my surface. The new deposit is processing. I can now drag it inside the scene. It is going through all the contact between the tuff and the basement. The next step is to build the volumes from the surfaces. For that, I open my surface chronology and I go in the chronology tab. They have to be in the chronological order from the youngest to the oldest at the bottom. So I put the basement at the bottom, basaltic flow 1 as the youngest, and to activate them, I click on the first box so that they all ticked, and then I click OK. Leapfrog is now going to use the surfaces to create the volumes, and the volumes will appear under the output volumes in my GM. I'm going to start by removing the surfaces from my 3D scene. First, I'm going to drag in the basaltic flow 1, then the basaltic flow number 2. We can also look at the basement, and all the rest will be considered as the tuff. Now if I press D on my keyboard to look from above, I'm going to do a new slice through my model by drawing a single line across the model. I can see here my two intrusions inside my tuff. If I want to see my well, I click on my lithology table in the shape list and I put it as unsliced in the slice mode on the property panel. Now we can see this flat area in the northeast model due to the boundary. So I can change the boundary of my GM by dragging the vertical arrows a bit higher. And I click OK. The model is going to reprocess to rebuild the volume with the new boundary. When it's done, it will update the volumes in the 3D scene. While it's processing, I'm going to change the slice mode of the basaltic flow by selecting Unslice for both of them. I can now see the two basaltic flows surrounded by the tuff lithology. To move the slice through the model, simply hold the Ctrl key on your keyboard and the right click of your mouse and move your mouse. By default, the model is oriented along the east and north axis. Here we can see that there are some areas where there is no well present. So we would like to change the shape of the model. To do this, you have to go in the boundary settings of your model. Right-click on the boundary, New Lateral Extend from a polyline. We are going to do a new drawing of a polyline on our model. Click OK. I'm going to start by turning off the slicer. And to see the wells, we're going to change the colors to black. So now we can see the well numbers. I'm going to use the pencil tool. We make sure that we are drawing on the object and not on the slicer. And now we can start drawing our polyline. A polyline to limit the extent of your model. Make sure you close the polyline. We can see it here with a bit more of transparency on the volumes. And now you can save. Leapfrog will reprocess the geological model with the new boundary. I'm going to turn a bit around the model to go back on the side. So if we look inside the boundary, we have our lateral extend, and those are the limits that are cutting our model. Now it's been processed, we can see that our geological model has a new shape that corresponds to the polyline we drew. This is now our final geological model. We can now see the two separated basaltic flows, and we can see the tuff and the basement. Now if we look at our well data, we can also observe that the same interval selection tool could be used for the different tuff formations. We can see three different, interbedded with the basaltic flows. Before making some changes in my units, if I want to keep this geological model, I am going to freeze it. I right-click on the GM and select freeze. This will avoid my model to be reprocessed when I make some changes. I can at any time unfreeze it if I want to restart the processing. I'm just going to freeze it now. I can now go back into my interval selection of the units. Under the lithology, I select the units. It will reopen the interval selection tool. I can still see here my two basaltic flows. I'm going to hide them, as well as the basement. So all I see now are the tuff intervals. First, I'm going to make the stroke tool line a bit wider. Click on 20 up there, and I'm going to change it to 50 meters. Now I can take the stroke tool. I press E on my keyboard to look to the east, and I select all the first intervals corresponding to the tuff formation. I am going to assign them to a new lithology. This one will be called tuff 1, and I will change the color to a yellow color, a bit lighter, and I click OK. This creates the tuff 1 formation, which I'm going to hide for now. Now, I'm going to take the stroke again and select the second series of intervals and assign them as well to a new lithology, and this one will be the tuff 2. I will as well change the color, pick a yellow, a bit darker, and click OK. Finally, after I hide the tuff number 2, I can select all the visible intervals left and assign them to a new lithology, the tuff number 3. And I will also change the color to a bright yellow and click OK. I now have separated my 3 different tuff formations, and I can look at them again. I can also reactivate the basaltic flows as well as the basement. And finally, I save all the changes I just made. I can now close the interval selection tool. The GM is not reprocessing. All the calculations have been frozen and they are showing here in blue. What we are going to do now is we are going to create a second geological model, also based on the units. We can see in the scene the boundary of the model. We're going to set a resolution of 100 meters. And for the boundary, we're going to use the same as for the first GM. And we click OK. The new geological model is being created. And if I look into the lithologies that I have imported for this model, I can see the basaltic flows, the basement, and the free tuff. Now if we look at the different units we have created on our wells, we can see that it will be possible to use deposit surfaces to create our geological model. So we're going to surface chronology, new deposit from a base lithology, and we're going to start from the youngest one at the top, which is the tuff number 1. We use the contact below, and the tuff number 1 has 17 contacts with the basaltic flow 1. We click OK. We are going to do the same for the next contact, new deposit from a base lithology. And now this will be the contact of the basaltic flow 1, the contact below, with the tuff number 2. There are 17 contacts, and we click OK. We can reproduce this with all the following contacts. The tuff number 2, contact below with the basaltic flow 2. Click OK. Now a new deposit for the basaltic flow 2 and the contact below, which is the tuff number 3. Click OK. And finally, the last deposit is the tuff number 3 and the contact below with the basement. And we click OK. Once it's processed, we can import all the surfaces to make sure we didn't miss one. We can see here a surface for each of the units. And this is what we are going to use to create our volumes. So I go into my surface chronology, and I will reorder the different surfaces from the youngest to the oldest. So the contact between tuff 3 and basement is the oldest. The contact between tuff 3 and basaltic flow 2 is right above. Contact with basaltic flow 2 and tuff 2. And the youngest one is the contact between tuff 1 and basaltic flow 1. And finally, we tick the first box to activate all the surfaces. And we click OK. The model is now processing to build the volumes. And we can find them in the output volumes folder. So I'm going to start by removing the surfaces from the scene, and instead I am going to import the volumes. And this is our geological model. We can see that it's a bit different than the first geological model. I'm going to slide through it. We see that it is still matching with all the well data, but now the basaltic flows expand all the way to the boundaries of the model. Similarly to what we done in the first geological model with the boundary, we're going to cut the model using a polyline, but we're going to reuse the one we built earlier. So we go back to the GM number 1 and select the polyline. We can see it here. What we're going to do, right click on it and share it so that it goes into the polyline folder and can be reused in other objects, such as the geological model number 2, where we go into adding a new lateral extent from a polyline. But this time, we select an existing polyline, which is lateral extent, and we click OK. The model is now reprocessing with the new boundary. We're going to reactivate the volumes, clicking on the eye. So here we see the geological model has now been cut by the new lateral extent. Now I'm going to clear the scene, and I'm going to show you how to look at the two models together. We start by dragging in the first geological model, but we also drag in the second geological model. We can either activate one or the other. So what I'm going to do, I'm going to press D on my keyboard to look from above. I'm going to take the slicers and draw a line in the middle of the model. The first GM will be sliced from scene, and the second one, I'll remove the front. So on one side of the slicer, I have the model number 1, and on the other side, I have the model number 2. Here again, I hold the Control key on my keyboard and the right click of my mouse, and I move the mouse to displace the slicer. This is the end of this webinar. I hope that you enjoyed it and that you've learned something new. If you have any question, do not hesitate to contact us at support.energy@sequent.com. Thank you for watching this video.